Hello, and I'm glad that you could join. Today we're going to be talking about AI malware analysis with Falcon X. So I'm going to be showing you how to do that, how to analyze advanced malware strains in a cloud environment. And for that, we're going to be using the Falcon X. Now, let me zoom this down. My face is not important. This is the images that I have, the diagrams that I have prepared. And let me show you this, quite a few. 1, 2, 3, 4, 5, 6, 7, 8. It is not many, 8. Just 8 diagrams. I can use the iPad to be drawing on the diagrams and to explain how you can use Falcon X to analyze AI malware. Now, why am I doing this? On January the 3rd, I have a 4-hour long session tutorial on AI malware analysis for cybersecurity. If your company provides you with access, you can join in for that. They still have some slots. This is with Pearson, so most of the large companies and universities have access to that. University of Oxford has access. I didn't even know until I tried to log in. More about CrowdStrike. There are various different products from CrowdStrike, and there are also Falcon alternatives. So, for example, this it's a Falcon AI model. We're not going to be talking about Falcon 40B. That's not the type of Falcon that we're covering. More about Falcon 40B you can find on the internet. The Falcon AI that we're using is this one from CrowdStrike. And why are we using CrowdStrike? Well, in the series of the videos that I'm going to be recording, I'm doing demos of 8 different projects. And CrowdStrike Falcon X is one of the best ones. So this is the one that we're going to be testing today. And specifically, we want to know how you can use the Falcon X to analyze AI malware for cybersecurity purposes. Now, if you're interested in this kind of content, and if you don't have access to O'Reilly, and if you don't have access to Pearson, you can subscribe to my YouTube channel, which is this one here, AI School Oxford, and you can watch the videos that I'm recording in preparation for the session. So that's going to be a long session. It's going to be 4 hours non-stop, and these are the short videos that I'm preparing for that session. Those would be like 20 minutes or 15 minutes demos. So I have, for example, this one on Deep Code AI and Black Mamba polymorphic malware. Or if you're interested in more lightweight content, I have a second channel. Hold on, let me stop that. Where I'm talking about how to earn free cryptocurrencies by testing different projects. So that's quite easy and easy to digest channel. As I said, this is the training on 3rd of January. There is another training, if you missed that one, on quantum AI and security. That is on the 10th of February. And I'm going to be recording those videos in preparation for that session at some point in January. So now I'm recording the preparation for this one, for AI malware analysis. Now let me just see if I have missed something here. No. The types of products that they have here we're going to be using this one, the cloud. And if you want to check what's happening with CrowdStrike, they have various different products on their marketplace. It's a big company, they have good products. But again, it's going to be one of multiple products that I'm going to be discussing in this. So we're going to have 8 segments. So those are segments. And for each segment, I'm going to have an exercise. And actually, I'm going to focus more on the open source, the freely available, like Guidra, as opposed to CrowdStrike. So that's why this video is more important, because I don't know if I'm going to be able to go into that much detail in this kind of a commercial software. But let's shift now to the iPad so we can review some of those images that I have prepared. We're in the iPad now, so as you can see, I can draw. And let's start from the very first slide that we have on Falcon model. Actually, before we get into this, let's talk a little bit about behavioral analysis with Falcon X. Falcon X employs AI models to improve malware analysis by observing the behavior of files. Hold on, what happened to that? That's why I'm doing this in preparation, because I always need to... Okay, let's choose red. Yes. Let's see if I can change the actual line to make it... Yes, okay. There we are. So Falcon X uses AI models to observe the behavior of files in a controlled environment. And then it relates that with, let's say they have a database of known attacks. So when they observe the behavior, they always compare against that database, against known attacks and patterns and anomalies. And behavior analysis is applied to identify, but also to neutralize malware strains. So especially those that they are targeted in the cloud environment, because remember that CrowdStrike, it operates in the cloud. They can give you a little bit of a device like a sensor, and you can install that in your operating environment, and within 5 seconds you're going to be able to start using CrowdStrike. So that's how easy it is, and that's the benefit of commercial software versus in the last segment I'm going to be talking about Bayesian optimization, which it's not that easy. It's going to take a lot more than 5 seconds to deploy. But Bayesian optimization, you can build your own system for free. Then you don't have to pay to somebody like CrowdStrike. Moving on, why is Falcon X very helpful? Well, specifically for polymorphic malware and fileless threats. So if something is happening in the cloud, then you can analyze the malware using AI for dynamic behavior. And the tools require very advanced capabilities for that. So the Falcon X would offer a framework for analyzing malware in a cloud ecosystem. It enables cybersecurity to specialists to develop understanding of the behavior of the malware and its impact. So I think that's more or less enough of. I don't want to do a promo. They didn't pay me to do a promo for them. So let's see what their software can do. So when you're performing the behavior analysis with Falcon X, first you need to prepare the environment, and that includes isolating the malware in a controlled environment to observe the specific and to record its behavior. And the specific actions that you need to take are those. So you can deploy virtualized environment, for example, Amazon Web Services, the Cloud Formation, or Google Cloud Sandbox, and that needs to be configured with specific logging and monitoring tools, which would be provided by the commercial software. Then you need to integrate the Falcon sensors. Remember, that's the little box that I said that you can install in your environment, and that's going to monitor the cloud performance that you have. So you need to install that sensor into the environment, like Amazon Web Services, Google Cloud Sandbox, to monitor and to process, to monitor all the processing that is happening. And that would include the file interactions, the API calls, and this specifically, the API calls. Now, if you watch some of the previous videos, you know by now why do you need to monitor API calls to detect polymorphic malware. And if that's not clear, then you can stop the video and go to the YouTube channel and watch the Black Mamba polymorphic malware video on my YouTube channel. And then this will become clear. Otherwise, the video is going to get really long and nobody's going to watch it if I cover every single step. That's why I record these short videos, which will be part of the 4-hour session. The third step that you need to do is you need to configure isolated subnets to ensure the malware network communication can only interact with the sandbox simulated environment. So you don't want to let the genie out of the bottle. So that's the setup. And then for triggering and capturing the malware behavior, what would be the objective here for triggering and capturing the malware behavior? Well, you need to execute the malware in a safe mode, then you need to monitor the environment to reveal the dynamic behavior, and once that objective is achieved, you need to do a specific list of specific actions. So one specific action is here, it's listed as detonate. I'm going to get into that, but let's first cover the execute. You need to execute the malware in this safe environment, which is monitored. So that's the first step. How is execute and detonate different? Detonate can mean different things in cybersecurity language, but in this context, quite often, usually it means the same. But let's expand it, because you're going to see detonate. You're going to see it more often than I think it should be used. So what could detonate mean to a cybersecurity person? First, it could mean that the marketing team behind the project, they realize that they need to figure out a new catchy term to get your attention. That could be the first things. And after a few hours of creative meetings, they came up with the wrong malware explosive analogy and decided to use the word detonation to describe a random event of the simplified scenario sketched up on their whiteboard. That is the first definition. But there's also a second definition, which is a little bit more useful. And that's, again, depending on who you ask and what side of the fence you are. Do you have a black hat or do you have a white hat? It could mean two different things. First, and this is probably the most accurate, at least in my opinion, is that the payload will be triggered in a sandboxed environment to isolate and analyze it. So this detonate means that the payload is triggered in the sandboxed environment. Then researchers and vendors will do this to identify a particular payload, if this payload contains malware, and then try and learn more from the actual payload. And if you're on the other side of the fence, it could mean that a piece of malware has been sitting dormant, and given a specific input or condition, it will be triggered and it will do whatever it was designed to do. Now, as you can see from those two scenarios, this is the reason why I felt we need to explain what does it mean detonate, because quite often it means the first one, that the marketing team is just wanted to use another word which is similar to execute. But there could be a second option which is used by black hat or white hat, and specifically the second one, when a black hat hacker would have a piece of malware that's been sitting dormant, and then they're trying to give it an input on a condition to trigger, and that malware would to do whatever it was designed to do. That could mean detonate. So that's why it's important that you understand that part. But moving on, once you have done those steps, so the first one, the second, the third one would be to monitor and log the process creation, including DLL injections and system level changes. And then you need to capture metrics such as CPU, memory usage, and execution patterns. Now, the underlying technology here, hold on, I have a joint diagram next to it. The underlying technology of Falcon X AI uses deep reinforcement learning. And I think this is important to cover, because quite often when you look on their commercial webpage and you want to find out what do they do and how do they do it, you can't. So you need to really dig deep into their small prints of their guidance document to find out that they use deep reinforcement learning models to predict and log probable payloads and to trigger conditions based on observed initial conditions. So this is the actual technology that they're applying. That's agentic AI. So deep reinforcement learning. Reinforcement learning is used by agents, and just for clarity, we have recorded previous tutorials on this, but there's 3 different types of AI: supervised, unsupervised, and reinforcement learning. And reinforcement learning then leads into Q-learning, and then we have AI agents. So those are the most advanced form of AI at this present moment. Why? Because supervised learning is just, and unsupervised learning, they are just categorizing apples and pears. With reinforcement learning, you send this into the real world, and the AI is observing things as they're happening, and they're feeding data back. So it's adapting and then proposing different strategies. So what else? What else do we have? Telemetry data. These models, for example, are based on telemetry data for over 200 billion daily events. And those are sourced from CrowdStrike deployment. So that's 200 billion telemetry data. It's a significant number. And the more data the algorithm has, obviously, the better it will perform. Now, moving on to step number 3, which is to analyze the network traffic and the command and control communication. What is the objective here? The first one is to detect and analyze communications with C2 command and control servers. How do you do that? Specific actions that you need to take is to use the Falcon X AI traffic analysis module to trace DNS queries and HTTP headers and TLS handshakes for signs of malicious activity. Then the second would be that's the first step of the step 3, so 3.1, 3.2. Second would be to deploy the Falcon domain attribution model, which uses graph neural networks, which is trained on historical telemetry data on command and control servers, such as command domain generation algorithm. This is usually written abbreviated to this. It stands for domain generation algorithm and IP reputational datasets. And what are the key insights from this? Well, it uses shared infrastructure, then reused DNS servers. What else do we have? We have IP blocks, and we have historical databases, which we mentioned, and APT tactic infrastructure. Those are the key insights from this specific step. Now, moving on to the next step, deobfuscation malware logic. The objective here is to reverse engineer obfuscated code to reveal its original functionality. So that's the step, and code reconstruction module is used. Specific actions would include using the Falcon X code reconstruction module, which is powered by variational autoencoders to detect and unravel polymorphic or metamorphic code transformation. And those variational autoencoders are trained on malware samples, again from CrowdStrike's database of 4+ million unique malware hashes. And that's focusing on identifying invariant operations, logic across obfuscated samples. And third step would be that Falcon AI compares these obfuscated functions to pre-existing function signature libraries, which are both benign and malicious, and it's trying to identify behavioral patterns. If we look at the use case, how could this be used? Well, a piece of malware can modify its encryption routines to evade detection, but with the variational autoencoders, you can recognize common sequences related to cryptographic libraries, which are used in ransomware families. Now, moving on to step number 5. memory analysis, and fileless malware detection. What is the objective here is to analyze memory-resistant malware that avoids detection by traditional disk-based scanners. So specific actions that would need to be taken here is to use the Falcon AI memory forensic module, which again applies convolutional neural networks to analyze memory dumps and to identify malicious code segments. And now I know it takes 5 seconds to deploy it, but to dig out all this information, it's not easy when you're trying to find out what specific step is doing. For what reason commercial software companies are hiding that information? Are they really hiding it? They're not hiding it, just that most of the buyers, they just want 5 seconds deployment that would protect their cloud environment. They don't want to know what specific memory forensic module is used, and do they employ convolutional neural networks to analyze the memory dumps and identify malicious code segments. Then the next step would be to identify process hallowing with a code injection or unauthorized memory access by comparing runtime memory patterns with Falcon X signature database. And third would be to perform stack tracing to understand how malicious instructions are executed in the system memory. And the underlying data, if we're talking about what kind of data is used, well, the CNNs, the convolutional neural networks, are trained on millions of memory dumps from legitimate processes and malware samples. And this allows the model to distinguish benign anomalies from malicious code. Now, looking at step number 6, the threat attribution and reporting. What is the specific objective here is to classify the malware strains and to identify its origin and what specific action you could take to identify that. You could use the Falcon X threat attribution engine, which combines behavioral patterns with metadata analytics. Second, you could use the engine natural language processing model, which is trained on CrowdStrike threat intelligence report, to link observed malware behaviors with known threat actor campaigns. And finally, you can generate report that includes observed behaviors and payload delivery mechanisms, IOCs such as file hashes, IP addresses, and suspicious API calls, and attribution to specific APT groups or newly identified malware families. Those are the things that you could include in the report when you're generating the report. Moving on to step number 7, how do you build custom defense mechanisms? You could create proactive detection and mitigation strategies. That would be the objective for this. And what specific action you could take? Well, the first would be to use the detection rule builder to create custom Yara rules or behavior-based triggers. Second would be to integrate these rules into Falcon platform of block malware at the initial stages of the attack lifecycle. And third would be to update firewall and the endpoint policies based on the IOCs and behavioral patterns observed during the analysis. One example implementation would be to deploy automated responses to isolate endpoints exhibiting behavioral such as repeated unauthorized file access or executive outbound traffic. That is it. So now you know how to use the Falcon X machine learning models to understand malware analysis. So this is just a conclusion section here that how do you use Falcon X? Well, first you need to deploy their graph neural networks to identify relationships between domains, IPs, and malware samples. This would enable threat attribution and infrastructure mapping. So second, graph neural networks are trained on the telemetry data from DNS logs and DGA patterns and historical malware campaigns. So now you know how these things are done. Then the second step would be variational autoencoders. You could deconstruct and simplify obfuscated code, and this would uncover operational logic and consistent payload behaviors. This is trained on datasets containing polymorphic malware variants, focusing on invariant features across samples. Third step, the reinforcement learning models. You can simulate attack scenarios and predict how malware might adapt to changes in the environment. And this is trained using stimulated environments that replicate real-world cloud workloads and security configurations. And four, the convolutional neural networks can analyze runtime memory and can identify injected malicious code or anomalous execution patterns. And this is trained on memory dumps from compromised and clean environments. And then the fifth one, the natural language processing. It's a process that is applied for threat intelligence reports, incident response documentation, and malware sample metadata for contextual threat attribution. And in a final comment on this specific software that you could use for AI malware analysis is that the behavior analysis capabilities are quite advanced, mostly for a cloud environment. And you can combine these machine learning models trained on very large global telemetry datasets with real-time monitoring and automated threat intelligence. And this platform would enable you to detect and neutralize threats efficiently. Each step in this guide that I explained here, which is listed in these figures, highlights the importance of integrating static and dynamic and behavioral techniques. So in previous videos, in other videos, I talked about static analysis of AI malware and dynamic analysis of AI malware. So now we have covered the behavioral analysis of AI malware, and you can adopt these all three methodologies to stay ahead in evolving AI cyber threats. But again, it requires a combined approach, not just behavioral analysis, not just static analysis, and not just dynamic analysis. You need to deploy all three, which means you need to watch my other videos. See you in the next one.